Assalamualaikum warahmatullahi wabarakatuh, and very good evening. Okay, we just continue with the part 2, chapter 4. Okay, from the previous lecture, from the yesterday's lecture. All right, so I think about half an hour, and we will discuss about the midterm. I will give you like such a hint for midterm. At least you got the idea, okay, what's to focus and to study, because this one is face to face. Semua orang rindu untuk face to face exam, right? Okay, cooling tower. So we know that the system, the complete system for the chiller system, or especially for the commercial building, that consists of three elements. Okay, three elements, which is the first one is chiller plant itself. Okay, so chiller, I did mention about the component of the chiller itself, that consists of condenser part and also evaporator parts. And the main purpose of this combination, to create consistent process of flow to create consistent temperature for the chill water to supply. Okay, and also the cooling system, the cooling tower. So cooling tower is the another part or system to supply condenser water to the chiller. Okay, so we have many types of cooling tower, and this purpose of cooling tower, or the objective to put the cooling tower, is to supply the to remove the device that remove or transfer process waste heat to atmosphere. Okay, to pass the heat to atmosphere. That's why we call it as cooling. Okay, the main component is fan, and also they has been put by a motor to supply to switch on the fan by using a motor. Okay, so three types of CT, we call it as CT, called CT cooling tower, by airflow generation method, natural draft. This one, I think most of these type of natural draft, okay, they put on the nuclear power plant. Okay, and the very common use for the chiller system is type number 2, mechanical draft, which is this one use motor to drive the fan. All right, and then some kind of water flow from the top to the down to remove the heat to the atmosphere. And the other one is a fan assist natural draft. Also, this one I think that has been used in biggest, I think in most of the bigger manufacturing related to heating process, etc. And they put something like here, like a tower to release the heat to the atmosphere. So what's the main process is cross flow to remove the warm air to the outside, and then to change the heat water to the condenser one. You can see here the water flow. The water come from the chiller, the hot water. I did mention about the temperature as well. So about 37 to 39. Okay, frequently we can find this temperature for the from the chiller to the CT. And then after that, through the process, we have fan here, you know, and also the flow of the hot air can be released to the atmosphere, and the hot water will flow. This one is the dry air. Dry air is needed to what we call it, to supply the air, to release, to change from hot air to condenser water or cool water out. This one 32 or 31 degree to 33 degree. Okay, outlet from this one will go to chiller. We go to chiller. Contour flow is the flow design that air flow is direct opposite to the water flow. That one is water, and air flow is kind of from the side, dry air in, and will go to the up to the top of the CT. Okay, will flow out to the atmosphere. So the fan is something like different with our home fan, because this fan will move the air from bottom to the up to the top one. How to calculate the effectiveness of the cooling tower? By using this one. Okay, range. Range. What's range? Range of the cool water, the piping. Range of the location of the piping, the inlet and outlet. So into the tower, something like here, and out from the tower. So this one is the range number 1. Okay, the range. So the range in maybe in meter. Okay, you can put any unit, and the other parameter that we need to measure is from the wet bulb, the wet bulb ambience, the what we call it, the level that we put wet bulb temperature, and the cool water pipe out from the CT. Okay, so plus range plus approach 1 multiply with 100, so we can get the efficiency effectiveness of the cooling tower. And also we can like a chiller, we can use this one again. We can use this formula to calculate the cooling capacity for the cooling tower. Okay, this one you can use either one, the flow of the hot water flow or cool water flow, and T in and T out you can use temperature in to the cooling tower, which is about 39. Let's consider 39, and out about 32. Okay, so the flow you can measure any either one from the hot water temperature in or cool water temperature out pipeline, the flow. And then at the end of the day, you can get the cooling capacity, cooling capacity RT, still RT. Okay, after cooling tower, the communication process between cooling tower and also chiller plant, and the third component for the chiller system is ASU. ASU. So what is ASU? a device used to condition and circulate air as part of the heating, ventilating, or air conditioning HVAC system. In another countries, like in Europe or in US, in UK, they also consider heating and ventilating system. That one they call it as HVAC. But in Malaysia, we doesn't need to put heating for the commercial building because we are not four seasoning countries. Okay, so like in Europe, they need like two system, heating and air conditioning or ventilating. That's why they call it as HVAC system. So ASU can supply heating air or cool air to the room. But in our condition in Malaysia, we just consider aircon as the cool air to supply to the room. So what are the components of the ASU? The component of the ASU. Supply ducting. Of course, we need supply ducting to supply the air to the room. Fan compartment, okay, to blow the air. Flexible connection, something like we can put a flexible connection between supply duct and the ASU. Heating and cooling coil, okay, we need also cooling coil to change from liquid to air, from the chill water to the air cool side. Filter compartment, filter. So filter is important for the issue because we need to get fresh air and also to filter dirty kind of for dust. Frequently we can see many or abundant of dust in the ASU room. So without filter, the air supply, okay, will consist of the other particles, the dirty particles supply to the room, and it will affect the human body. Return and fresh air duct. So of course we need ducting for the return and fresh air. Okay, so return air from the room will return to the ASU, and fresh air. We need also fresh air from the outside. Okay, so must be ducting for the fresh air to get fresh air mixed. They will mix together with the return air from the room to be processed by ASU and supply again to the room. So auditing air conditioning system, what we need to have is system design to know what kind of system design that they have in a building. So by doing that way, we need to refer to the drawing, for example, okay, the equipment data. So get this all the information before we can do some suggestion or doing the auditing process. So desktop audit is really important so that auditor will get the idea on how they can audit the system. System audit overall efficiency and COP. Okay, to get the efficiency by measuring some parameter. Okay, we get the efficiency or COP. Room temperature and humidity. So if the chiller system or the BMS and building management system, we put 24 as the temperature control parameter or set point value for the aircon. So 24. Okay, so what happened to the room temperature if different, too much different? For example, inside the room, we measure the temperature and we got the value for the temperature is lower or really much different with the set point. So engineer must do something to ask whether to ask their technician whether this kind of the sensor is broken or something happened to the chiller system. And also for humidity, humidity. So to actually measure the humidity, it's really important, especially for the record room. For example, to store the book, to store the very important document, so they need to maintain humidity, humidity around 40 to 60% of humidity. Like the arcade negara for the library institution, so they need to maintain the humidity level at least 40 to 60 or 70. 70 too much. I think about 40 to 60. That's one the requirement for arcade negara to maintain. And then um, like fungus for the book is something like it's really bad for the storage one, especially for the book and important documents. Dia akan jadi berkulat ke kan. Itu yang kalau tengok dekat library is something that you can see dekat dia punya shielding kalau ada humidity tak betul, and then we need to do something to setting chiller temperature and also come out with the issue setting to get a fresh air percentage and to get the proper temperature, the special temperature. Issue audit set an actual parameter and air and water system. So fan motor power input control system BMS. So we need to refer also to BMS. If there is the available control room inside the building, they use the BMS, building management system or bus system, building automation system. If you are one of the auditor, so go to the control room and explore their BMS. You can easily understand, fastly understand their system. So for desktop audit, system design, air conditioning system equipment, chiller, so get the drawing for chiller, chiller water pump, condenser water pump, what types of the chiller, and the specification for the chiller, water pump, cooling tower issue. So that information you can get from the drawing. Okay, system design. So this is example of the chiller drawing. You can see here the chiller. They have two chiller, one and two chiller. So they have 3 pump for one chiller. Okay, one is standby. So they running two all the time, running two intermittent. Okay, so standby one, standby. So they have also divided by pump that for the condenser one for the city cooling tower, and also pump for the supply and return chill water. Okay, this slide shows the example of the cooling tower drawing. From here, okay, this one is I think chiller 1 and chiller 2. You can see here, this one cooling tower. Okay, cooling tower. So piping, we go to something like here. Chill water pump header. This one is healer, feeder for the condenser. Okay, the flow of piping here to the condenser one. Okay, flow of the piping to the condenser. And this one is evaporator, go back to the chill water pump header, which means to go to the CT1. A issue. This one A issue. Ni ducting lah ni. Okay, we got room number 1, for example, room number 2, room number 3. So ducting from A issue. This one A issue. A issue. Supply, ducting supply to the room. And there is must be dual component of supply and return air. So maybe this one is the return air. Supply and return to the issue. Okay. InsyaAllah lah minggu depan Tapi ada yang nak balik lah minggu depan. Ada yang minta balik awal.
Ada doktor?
Ada kan?
Ada.
So minggu depan kita nak buat face to face ke nak online?
Bergantung pada majority.
Ada nak balik awal, tak apalah. Kita buat online lah kelas minggu depan. Boleh? Nanti next lah. Awak datang balik next naik cuti nanti kita pergi visit.
Okey doktor.
Demokrasi. So issue. Issue, okay. This one supply ducting. Supply ducting from A issue. Okay, supply this one to room number 1. Okay, here room. We got diffuser over here. And also from a supply to return air. Must be a return ducting as well. So the return from the room air will be returned to the A issue again. And A issue, there's the mix, the process of mix air over there. So we can have the fresh air from the outside mixed to the together with the return air. And this mixed air will be supplied again to the room. All right, this one is another example from the building management system or bus system on how they set the issue. For example, issue number 1, the status is on, okay. Set point, supply temperature, return temperature. This one is set point. Okay, so flow, chill water supply, chill water return, or everything, the parameters that need to be monitored by this BMS. Okay, this one image for the issue. We got motor here. Okay, chill water supply, from chiller to issue about 8.4. 8.4. So this one air, supply air. The temperature for supply air here is about 16. And return air from the room to the issue about 33.1. Okay, so 33.1, this one will be monitored. Okay, because the set point, the sensor for the set point will be put at the return side, return air side, not the supply air side. If you set the set point 24, 24 is the return air, not the supply air. Maybe the supply is something like this, 16, 18 degrees Celsius. So the set point, if you want to set the room to 24, and we need to set to get the set point about 23 here at the return air. So we got to know that the room now is 20 something degree from this return air temperature. So we got two temperature here to measure the set point temperature and also to maintain to measure the return air. Okay, the set point is 23. On how they will maintain the 22 or 23 near to the set point is to regulate the actuator valve here. To regulate the actuator valve here. So if a valve is open 100% and it will operate the motor in 100% operation. Run the motor 100% operation, and also will draw the chill water or airflow to the chill water flow to the maximum, the flow rate to the maximum one. If you can monitor, can reduce the actuator valve percentage to open about, okay, when the system will react something like this, when the room temperature, okay, is near or over, a bit over than set point, or near the set point and achieve 22, and then suddenly the actuator valve will be closed and maintain the condition of the flow rate for the chill water and temperature supply for the supply air side. Okay, if something like this, we set the set point, the room return air is about 24 or 25, 25, 26. The actuator valve, the set point is 22. The actuator valve will respond, okay, to decrease the temperature to 22 or 23 plus minus 1, and the actuator valve will be opened again. Will be opened again, and will draw the motor to the maximum operation, and also to get the flow and the chiller to supply more chill water, or in the more volume of the chill water to the AHU, and it will increase the consumption of electricity. Okay, that's it. So if the building doesn't have this kind of the system, and you as the engineer or maintenance engineer should suggest to your boss, hey boss, this one, BMS, we install BMS and all the sensors so that we can control it automatically to get avoid the waste of the energy. Instead of however, if you doesn't have this one, okay, your energy will consume at 100% without any automation control. Your running operation in 100% all the time, for example, motor will run 100% all the time, and also your chiller system will operate at the full capacity load all the time, because you doesn't have this kind of the control or respond to the room temperature. Okay, So this one is the overall system diagram. Cooling tower, condenser water pump to pump the water to the chiller. Okay, we got a condenser and also evaporator. So the process of the chiller and supply what? Chill water to the chill water pump to help to supply the chill water to the AHU. Okay, from AHU back to chill water pump and back to the chiller, and chiller back their hot water back to cooling tower. Okay, that's the process. The condensed water, the cool one will go to the pump, and the pump will send to the chiller. We flow the water to the chiller. The chiller, from the chiller again go to AHU, the chill water. So the process is something like here. So for AHU will turn the chill water to air side, to air side. So supply the air side, okay, supply the air side through the ducting, supply air terminal to the room, and the return air back to the AHU. Okay, so all the sensors here, for example, to set the set point, the valve, the actuator valve to control the valve open, and also for the temperature to measure the supply and return temperature from the pipeline, from the chiller, return and supply, and also for the air side return and supply. So all the information will goes to building automation system or building management system. Ni record lah, condition equipment must be record. Okay, template, equipment data, something like this. Okay, to get the chiller, you can get from the plate, from the information plate that has been put in chiller. So you get all this information from the chiller system, or even though you can get from the BMS, the rated one, and also for the OEM, the manufacturing condensed flow rate, evaporator flow rate, you can get from the chiller itself. And also for pumping system. This one is the example on how auditor collect the desktop audit equipment data from the nameplate, for the nameplate of the pump and also for the chiller. And the most important information also, you need to ask the operation time for all the components. Ask the operation guys, okay, operator or technician or engineer, ask them on how they operate the pump or chillers or compressor, hours running operation. So jot down all the information to the audit sheet. So equipment to be audit, system energy audit, equipment to be audited, total power, chiller water pump, condenser water pump, cooling tower, AHU. Okay, so what kind of measurement device that we need is our ultrasonic flow meter. This one to measure flow rate, to measure chill water flow rate. Temperature meter. At least you need to prepare a temperature logger, because during the process of logging for the flow rate, chill water flow rate, simultaneously you need to put a temperature logger to the chill water supply and chill water return. Okay, so back to the formula of the purpose of this, all the measurement device to get the value to calculate the kilowatt per RT, to calculate the RT1. to get the COP. So RT on how to get the refrigerant ton, the cooling capacity is 4.18 multiply with Q multiply with delta T. So Q is measured by using this flow rate meter, and delta T by using a temperature logger. So at least 1 week, 1 week. Power meter to measure at the DB site or MSB site for the chiller plant to get the if you want to get the COP for chiller number 1, okay, please get the power consumption for the chiller number 1. At least they are concurrently running, measuring device concurrently running. If you take 1 week for this flow rate, and also you need to take 1 week for the temperature and also for the power consumption. So these 3 devices must be run simultaneously for 1 week. Temperature and humidity meter. So this one we need also to get the temperature and humidity meter at the chiller plant. Okay, the example of the data sheet for the chiller plant audit. This one. So record all the thing. If you have this one, chiller water temperature, operation hours, okay, and power rated. Temperature measurement. Okay. I think that's it. Nak lagi? Ajar lebih-lebih korang tak nampak ni sebab tak tengok chiller lagi kan? Betul tak?
Betul.
Betul tu.
So,
Gila doktor.
kita berhenti kat sini dulu sebab nanti sini nak kena ada measurement ni kan. Ni at least you all know on how to get the information, main intake, whatever ni. Nanti kita go to chiller plant tengok chiller 1, chiller 2 ni. Okay? Okay. So we stop until here. Remind me next week for this to explain. Tapi kalau yang nada tak balik lagi, Isnin tu kita set lah, kita turun ke chiller plant. Kalau ada yang tak ada yang nada di UTM lah. Siapa nak turun nanti datang ke kelas.
Okey
Hari
doktor.
Selasa tu kita tak buat face to face lah, kita buat online. Cumanya Isnin tu kalau ada yang tak balik lagi datang, kita buat face to face. Kita pergi round FKE punya chiller plant, tengok isu, tengok cooling tower. Cooling tower kita dah boleh naik atas lah. Saya dah buat tangga tu. Dulu tak ada tangga. Alright. Okay, so apa lagi? Dah, itu saja. Setakat tu. Cukup
Cukup doktor, cukup.
Okay. Saya ada meeting dengan NC kejap lagi. Pukul 3.30. Apa lagi saya tertinggal ni? Cukuplah.
Manis-manis doktor. Manis-manis.
Manis-manis apa tu?
Hell.
Okay. Sekejap Saya nak suruh awak buat ni dulu. So try this one. We try to calculate this one. A small industry operation day and night. Okay. Exercise sikit lah. 7 days a week. So running 24 hours lah when it is the question state that this small industry operate day and night. So means that means 24 hours, 7 days a week. and consume about this amount of kilowatt consumption, and also kVAR given kVAR reactive. This one is reactive per month. So per month. So this one is per month energy consumption and reactive power per month. The maximum demand is 1,200 kilowatt. So calculate the electricity bill using tariff given as follow. So first of thing to do is to determine whether, okay, we know that this small industry, if you directly calculate their energy or the electricity bill, okay, by using kilowatt hour multiply with 28.8 or 0.288, you can get the price for the energy consumption plus maximum demand, 1,200 kilowatt, 1,200 kilowatt multiplied with 20.3. That one plus two of this component, those component will give you the electricity bill. But if the question give the information something like this, okay, with kVAR, kVAR hour information, and that's the hint. Please consider to calculate to verify their power factor. Because the other component I did mention about the other component of the electricity charge is power factor, CLC, for example, okay, the other charge, ICPT rebate, etc. So if the question give the information about the kVAR, please make sure you got the value for the power factor, the current power factor. It's not your question, your answer is not fully you can get you can get the full marks for your answer. So please consider power factor. Like this one, okay, on how you can verify it by using this one is the usage, the usage of kilowatt hour. I did mention the kilowatt hour. This one usage for MD, and the other one is power factor penalty. So power factor penalty, on how to calculate the power factor by using this one. We got the P here and also Q. Okay, so PQ power factor tan P over Q, kan? Okay.
Kan Q over P.
Q over P cuba kira. Tan, nak tan. Q over P cuba kira. Dapat tak? .78. So we know that we have two condition of power factor. If you got this value, okay, so the first one is 0.7 to 0.85. Also multiply with 1.5%. This one is 7 unit, 7 unit. So please do many exercise and go back and try to understand the power factor calculation in chapter 3 on how they charge the power factor. Okay, you got something like 10.5 multiply with the total electricity bill plus this This one, not plus, this one. The charge for kilowatt hour.
Betul.
Yeah.
Soalan sama dekat chapter 3 tapi situ power factor dia 0.71.
0.
7 point.
Cuba kira balik. Dapat tak?
Kalau 0.71 tu formula dia saya pakai kilowatt over set kilowatt hour square plus kVAR square. Dapat 0.71.
Dapat point? 0 point?
0.71. Saya ambil formula dekat nama WTMB.
Oh, dulu kita pernah buat kan? Kat chapter 3
Kat chapter 3.
Awak guna formula mana?
Saya pakai formula kilowatt hour
Ni kan, bahagi dengan ni kan?
bahagi dengan kilowatt hour square plus kVAR square set.
Okey. Okey. So boleh dapat 0.71 sama dengan yang tu.
Sama dengan dekat chapter 1.
Okey. You can use the triangle punya ni lah. Macam ni Betul?
Betul. Atau atas dia yang ni bahagi dengan kilowatt hour bahagikan dengan yang set tu.
Okey. Kilowatt hour tadi 560 ni bahagi dengan ni kan? Betul? Boleh dapat 0.71. Refer yang tadilah. So if 0.71, so that's mean two condition lah. Right? Ni recheck balik yang ni. So I think better you do refer that exercise and recheck balik on how you can get the power factor and then come out. The process is the same process, but the important thing is to get the correct value for the power factor. Okay? Ni kena buat balik lah untuk test preparation nanti. So which mean please consider if the question asks you to find the total electricity bill, okay? Please consider the power factor charge if the question gave you the information about the reactive power. Senang macam tu je. Okay, for midterm, dah 257 dah. Midterm, kita ada